This is the outline of this video. We have shown you the overall connecting topology in the very beginning. The next section is introduction of this demo box. And then is how to power on the AP and N nodes. Before set up the AP and N nodes, there will be connecting topology between a module and a laptop. After setting up, we can monitor the communication results between these three modules through LED status, the active status on the AP, and we can query the data on the AP web utility. In the log session, there will be a demonstration about using a laptop to read data through Modbus TCP protocol. Now let's get started. This video is going to introduce about WISE-4210 series, IoT wireless sensor node. WISE-4210 series is using proprietary protocol, low power WAN, which is defined by Advantech. Low power WAN is abbreviation of low power wide area network, which provides 923 MHz, 868 MHz, and 433 MHz radio frequency. This radio frequency makes this series capable maximum 5 km coverage if using 625 bps, or maximum 2 km coverage if using 50K bps data rates. Also, this frequency makes less network interference. These features of low power WAN make WISE modules an ideal solution for machine-to-machine, energy and environment, or any other IoT applications. WISE-4210 series allows a user using RESTful API, MQTT, or Modbus TCP RTU protocol to send the commands or query the data to or from the cloud, such as web service, MQTT broker, or Azure IoT Hub. WISE-4210 nodes accept both line power inputs and battery inputs. It has up to 5 years battery lives. The N nodes will listen before talk to avoid interference. The antenna are changeable. It is also flexible mounting for pole, wall, or DIN rail. This demo box demonstrates a scenario that a S231 with a built-in temperature and humidity sensor, and S251 with 6 DI channels and 1 RS485 port, pushing the data to the access points. Also, monitor the periodic data and change of states on a laptop through Modbus TCP from WISE-4210-AP. There are two options to power on the module. First option is using 3 batteries at one time, and each of them is 3.6 volts. The second option is using 24 volts power supply. Please note that the AP does not support battery input. It only supports 24 volts power supply input. Now, let's start with configuring a WISE-4210-AP. As this shown topology connects the WISE module and a laptop with a RJ45 cable. Run the WISE Studio on the laptop. Now change your IP of your laptop, because the default setting of the AP is in 10.0.0.1. So Make your laptop into the same subnet of the AP. After the setting, now refresh the WISE Studio. As you can see here, it's your IP address of your laptop. Click on Configuration. Studio will automatically search the WISE module in the same subnet. Click on the module, click on Connect, Login. Okay, now go to Configuration, RF module. These three parameters are the one need to be the same on N modules. So it will understand the data pushed from the N module. This is the topology when a user wants to set up the N node S251. Power on the N node, connect with one USB cable. The other side of the cable connect with your laptop. Run the WISE Studio on your laptop. Go to Configuration, Connect, and Devices. Okay, now this is your S251. Go to RF status. These three RF region, data rate, and baseband should be the same on your AP setting. This is my setting on the AP. As you can see, all these three parameters are the same. Here is data upload. Click on it. The default setting is the N node will push the data to AP every 600 seconds. If you want to set up change of state or shorter time, you can configure here. To make the demonstration quicker and faster, I'm going to set up every 10 seconds and change of status. Then click on Submit. Next, to configure the third module, S231 is using the same connecting topology as connecting with S251. Use a USB cable to connect with the WISE module with a laptop and run the WISE Studio on your laptop. Use the same method to configure your S231. Go to your USB serial port, connect with the module, and devices, RF module, and here set up the same parameters as the ones on the AP. After setting up the parameters on three modules, now let's go back to AP module. Connect with your AP module and log in. Let's check if the data is pushing from the N node and the AP can receive it. Go to the N devices, and here, these two MAC addresses are the module we were setting on. The Modbus ID is automatically assigned, but they are configurable. The RSSI are the signal strengths between AP and N module. Inactive time means how long ago the AP received the data. As you can see, I set up every 10 seconds or change of state. If the inactive time is more than 10 seconds, it means the AP cannot receive the data from the N module. The battery status and battery level, it will show different parameters if I'm using battery input. But now, as you can see, I'm using only line power input. This one is RTC battery status. This RTC real-time clock is to keep the system time inside the module even you power off the module. The last one is active. If you can receive the data from the end module, it will show active, otherwise it will show inactive. In this page, you can only see how active is the end devices, but you cannot see any data. So go to Advanced Data Logger, Local Data Query. Here, it can show you the data received from the end module. Current total amount. This amount means how many end module that AP is receiving. Now I'm only connecting to one S231 and S251, so only 2 modules active. You can query only the last data. Select the MAC address which you want to query. Click on Query. Here it shows the I/O type, and here is the I/O status. Each data, there are SSI signal strengths, timestamp, UUID, MAC address, and their channels, I/O type, and values. If you want to see about the data from S231, go back to the top, select the other MAC address, click on Query. Now this one is the temperature and humidity data. This one is temperature, and this one is humidity. This one is the minimum. Since you power on the module until now, the maximum data and the minimum value, this is the current status. So now this room is 20 degrees. Now I'm clicking the buttons next to S51. As you can see, the inactive time is very short because I set up the end module should push the data while change of state. Go to Data Logger, query again. The DI value has been changed. Please note that this Data Logger function does not contain the history log, only the last data. You can consider it as real-time pushing. If your server or laptop wants to query the data through Modbus, you can use either Modbus TCP or Modbus RTU protocols. Go to Configuration, Modbus, open your Modscan, click on Connect. Use Modbus TCP to connect with your gateway. Under the Modbus tab, on the right side is Modbus ID. The default setting is shown on the screen. The AP Modbus ID is 241. And this MAC address is S51. The Modbus ID is number 1. You can delete it or modify it. If you modify it, just click on Submit. Here I'm setting device ID number 1. I want to query the DI status. So go to Modbus address. My DI status is counter. So switch to holding register tab. Here is the counter value. The address starts with 17 and the length is 16. Go to registers. The address starts with 17 and the length is 16. Now you can compare the counter value. Channel 0 is 23. Channel 1 is 36. This architecture shows that one AP allows maximum 64 end nodes to connect with it. Thanks for your listening. Have a nice day.